Hi all, this is our 25th video installment for Math 2201, excuse me. This time we're adding and subtracting numerical and variable radical expressions. So we're going to talk about the requirements that we need to have in order to be able to add or subtract radical expressions. There are certain rules that we have to follow for that. And then we're going to talk about how do we add and subtract radical expressions that are numerical and those that are variable. Alrighty, so let's get to that. So here's sort of what we need to know or what we need to have in order to be able to do this. When we look at any radical term, as we know, it's sort of got three parts. It's got a coefficient, it's got this index here, and it's got its radicand. So you'll notice by what's labeled here, in order to be able to add two radical terms together, we have to have the same index. So like this first example, they're both cube roots, so that matches. And we have to have the same radicand. So both of those things have to be the same in order to be able to add them together. The coefficients, 5 and 2, they don't have to be the same. So when we add these together, we sort of look at this, as long as we have the same radical part, so the same index and radicand, it's kind of like having 5x plus 2x, where x is the radical bit that's the same. So that would give us 7x. So in this case, what we have is 7 times the cube root of 7. Okay, 5 and 2 are 7. Notice that in the next two examples, the first one, we've got a cube root and a square root. Nothing we can do to add those together, so we'd have to leave that expression as it is. And in the last one, although we have two square roots here, the indices match, but we do not have the same radicands. And without the same radicands, we're not in business here at all, so no deal. We got to move on. Let's see what else we got. So here are some examples of adding some radical expressions. So we see this is a square root 5 term, and this is a square root 5 term, so I can put those together. And this is a cube root 2 term, and this is a cube root 2 term. So it's like combining like terms. So I'm going to take 2 square root 5 minus 1 square root 5 and get a single square root 5. And then negative 7 cube root 2 plus 3 cube root 2 should give us a total of negative 4 cube roots of 2. And that's all there is to that one. In this next example, it looks at first sight like none of these are going to be compatible because we don't have any similar radicals or radicands or anything. But let's see what happens if we simplify them first. So we'll start with the 32. We know that square root 32 is the square root of 16 multiplied by 2. Okay, nothing I can do with the 5 square root 2 to simplify that. And the cube root of 1,000, well, 10 times 10 times 10 is 1,000, so that's just a 10. And then over here, 16 times 2 underneath the square root, well, I can square root the 16 part of that and get 4 root 2. So I have 4 root 2, subtract 7, subtract 5 root 2, plus 10. So now you can see that these terms are compatible, so I can add those together, as well as these constant terms here, or I guess they're all constant, but those non-radical terms. So we put all that together, and we're going to end up with a negative 1 square root 2, and then negative 7 plus 10 makes plus 3. And if you don't like to write the first term as being negative, although that would still be correct, you could write 3 minus square root 2. All right, so we can jump on. Here are some algebraic expressions that we have to add using the same sort of rules. So in the first example, we just sort of try to match up radicals. So we have a square root and a 3x and a 3x, so they look compatible. So all I have to do is take square root 3x and then add together their coefficients. So I'm going to add 5x and 12x. Well, 5x's and 12x's are 17x's. So I end up with 17x square root 3x. That's a bit weird and abstract, but shouldn't be too hard after you get a little practice with it. Then, in the second pair of terms here, I have a negative 5 cube root 7x and a 7 cube root 7x. So they should go together quite well. We should have a positive 2 cube roots of 7x. Okay. Now in the next one, this is where it gets a little bit mucky. We've got to deal with a whole bunch of ugly terms here, and we don't know whether we're going to be able to add together or not at this point. We have to try and simplify them all first. So that first one, we've got a square root of 27x squared. So let's take the perfect square parts out. 3 times 9 would give us 27. So I'm going to say this is the square root of 9. And from the 27 and from the x cubed, I can say that the x squared part of it is a perfect square. And then what's left over would be a 3 and an x. So you see the 3 times 9 was from the 27, and the x times x squared is where we got the x cubed. Okay, so we took the perfect square bits out of that one. Perfect square factors, I should say. So then there's not much I can do with negative 7x times the square root of 3x, because square root 3x is about as simple as it's going to get. And there's not much I can do with negative 8x squared times square root 5x. Square root 5x is nice and tidy as we're going to get that one. The last one there, though, let's see. We've got to take a 7, and then we've got a square root of, what's a perfect square factor of 125? I think 25 works. And a perfect square factor of x to the power of 5 is x to the power of 4. And then we put what's left over when we divide by those. So we have 5 times 25 is 125. And x times x to the power of 4 is x to the power of 5. Now we simplify and then we add. So the first one becomes 5 times 3x. When we square root this business right here, we get 3x multiplied by the square root of 3x minus 7x root 3x. And then we've got minus 8x squared, square root 5x. And then we have to add 7 times, looks like 5x squared times square root 5x. Okay, so over here we've got 15x and 7x, so that makes a positive 8x times the square root of 3x when we combine those like terms. And then on the other one we both have a square root of 5x, so we've got a negative 8x squared and a plus 35x squared altogether, so that's going to make a positive 27x squared when we add those together times the square root of 5x. And since we don't have any more like radicands, that's as far as we can go with that. Okay, so there's a quick summary. Only add when we have like radicands and indices, and we try to simplify if we can, and then we just use the algebra stuff we already know. Hope that helps.